Perfect. So let's go ahead and get started. Thank you so much, everybody, for joining the May edition of the OpenXLA community meeting. We have a lot to cover. We're going to try to get it done in about 30 minutes or so. So in terms of what we want to cover, it's divided up into two different parts. For the first 10 minutes, we'll talk about community updates, and then the last 20 minutes we'll focus on technical updates. We've got the AMD team, we've got the ByteDance team, and we've also got Stable HLO. So a lot to cover. So let's go ahead and get right into it. In terms of community updates, we do want to mention that OpenXLA got a huge shout out at Google I/O. It was highlighted in the Google I/O developer keynote as a key investment that's providing more optionality at every layer of the stack. So very, very excited about that shout out that we got. And in addition, we also had a shout out at Google I/O. There was a talk given by our very own Shaheen talking about accelerating PyTorch workloads. So definitely check that out. That's also available on YouTube as well. And then if your CEO wants to wear the OpenXLA t-shirt, we are happy to get one over to him. Jensen was a really great sport, and here's a great picture of him wearing the OpenXLA t-shirt. So super happy about that, and we'd love for your CEOs to wear them as well. So just let us know, and we can make that happen for you. With that, I'm going to turn it over to Cormac to talk about PyTorch on device.
Great. Yep, thanks, Adishi. Yeah, I'm going to do a really fast version of this because I think we've only a few minutes here. Yeah, so also Google I/O, we launched support for PyTorch on device. This is supporting PyTorch files directly down to the kind of TF Lite runtime, which is what we use for workloads on Android. And this is done, relying heavily on the work of the Stable HLO community. Firstly, we use kind of Torch XLA to get from Torch export into XLA, then we export to Stable HLO, and we kind of rely on the stable part of Stable HLO as an important part of the on-device story, because that artifact may exist for quite some time in Stable HLO format in a developer flow, right, and then be sent to a version of a runtime sometime later. And we rely strongly on the forward and backward compatibilities there. For lots more details, there's a blog and a talk also kind of linked here for more details, but maybe next slide. Yeah, and I guess, yeah, what we're bringing to developers is an easier flow. You kind of pip install AI Edge Torch. Yeah, you can see the GitHub repo there. And yeah, effectively that just allows you to call convert in PyTorch and get a TF Lite file that contains Stable HLO. On the right-hand side just kind of shows what that actually, what the flow is, right? We go from Torch export. Ooh. Aditi's,
I'm able to see it.
I'm also able to see.
Yes.
Yeah.
Are the
Maybe
same problem?
Okay. Okay, cool. I'll keep going. So yeah, on the right-hand side, you can see what the flow looks like. We go from Torch export. That's from Core A10. Then that goes into Torch XLA. We lower to Stable HLO, and then we run it through our conversion. We get a TF Lite flat buffer. So maybe next slide. Yeah, so there, like in terms of coverage, which is a kind of key area of concern, which is like, wow, what portion of PyTorch programs work successfully in this flow? Yeah, like really close partnership with the Torch XLA team, also with the Stable HLO team, to increase our coverage over time. Right, this is a kind of report from Q1 of this year, and we're at a point now where we can see that the almost everything we want to do in Core A10 is supported in Torch XLA. We also can see that Stable HLO itself is capable of, as far as we can see, that it's capable of representing everything that we need to represent in Core A10. And really the focus now is on our team in terms of kind of converter support and backend kernel support. We're up to kind of 70% of Core A10, but the elements of infrastructure, above the line from the TF Lite converter and up, they all have, excellent coverage of the Core A10 offset. So we're pretty optimistic about being able to kind of burn this down in the coming months. Maybe next slide. This is simple benchmark, just kind of showing performance on a Pixel 8 FP32 precision on CPU. And this is showing kind of relative to Onyx, which is another, I guess, kind of popular way to get from PyTorch and execute on kind of edge devices. Yeah, you can see here, like, performance is pretty good across the board. There's a couple of regressions, so we're going to keep an eye on. This performance work is ongoing. We expect to be busy eking out better and better performance over the rest of the year in this path. But, you know, for our initial kind of test set of models, we're kind of pretty happy with what we're seeing. Yep, maybe next slide. Yep, that's it. Yep.
Perfect. Thank you so much. Definitely reach out if you have any more questions about that as well. And then I'm going to turn it over to James to talk about the OpenXLA DevLab recap.
Awesome. Thank you so much, DT. I'm James Rubin, and I'm going to give you a quick rundown on what happened at the OpenXLA DevLab. Awesome. So for those who couldn't attend on April 25th or who are new to the community, we held our third ever developer event for OpenXLA and our first ever DevLab. The DevLab was a unique format that differed from our previous OpenXLA summits by focusing almost exclusively on interactive OpenXLA education through hands-on tutorials, as well as these use case specific office hours or lab sessions, as we call them. These lab sessions paired an OpenXLA subject matter expert with development teams in the ecosystem to work through their specific OpenXLA related challenges and projects. So this slide just shows some of the goals that we aim to achieve. So hands-on education, as I mentioned, personalized support through those lab sessions, but also finding, you know, future opportunities for collaboration on performance optimization for your hardware. We also want to make sure that all of the materials, all of the publicly shareable materials that we put together for this event, including the tutorials, the documentations, the videos, the keynotes, are available to the rest of the OpenXLA community. And of course, none of the lab session specific or company specific information will be shared. And then of course, we wanted people to connect with the brilliant people in this community. Next slide. This is just a brief overview of the event structure. I just want to highlight the keynote here in particular. This covered everything since the October 2023 summit, all of the wins, and also the 2024 strategy and some of the exciting releases that you can expect. So that includes things like Chardonnay and Palace and stable HLO features. Next slide. We had incredible turnout for this event. People from over 10 different countries attended, from as far as South Korea and Australia. So super thankful for that. Given how headcount intensive this was, we actually only planned for 50 people, but we ended up getting over 100. So we absolutely appreciate that demand, but also thank the OpenXLA engineers who stepped up to facilitate the event. So this is a blog where you can get just all the details on the event, in particular the keynote, if you want to deep dive on some of the specific features that we launched and some of the benchmarks. That's all in there. Next slide. The feedback. So the positive feedback, I'll just summarize it quick for you. People really love this event format. And so we're going to continue it into the future. But more importantly, we are looking for areas for improvement. So next slide. We highlighted really 5 areas that people called out the most, which was that people wanted to attend more tutorials. They wanted to attend a 3rd or 4th session on the day. They wanted, so we're going to figure out how to do that for the next event. They wanted the tutorials to be more interactive. We had some tutorials like the stable HLO tutorial, which were Colab based and hands-on keyboard. And we're going to see how we can leverage that style and apply it to future tutorials. Calibrating the tutorial skill level. So for some folks who are newer to the community, the difficulty level was not matched to their experience. So we're going to figure out how to communicate that better in the future. Lightning talks, we're going to have tons of those at the OpenXLA Summit later in the year, so don't worry about that. And then more swag. Some people are wearing their t-shirts to work, and we love that. They want a second t-shirt. Some people didn't get a t-shirt at the event. So at a minimum, we will have plenty of swag at the next event, and we'll see what we can do about people who want another t-shirt.
Exactly.
Yes. And then next slide, we have the OpenXLA Perf Lab, which we're just going to advertise today. which is, it's unfortunately not a way to directly improve your end of year performance reviews at work. It is, think of it like the dev lab, but for model developers. So we're going to focus on hands-on education to optimize performance of your workload. And, you know, again, those use case specific lab session deep dives specifically for model developers. But if you are a hardware developer, you can absolutely attend this event. It's open to you, and we want your feedback. So contact a DT or myself for more details. And with that, I'll pass it to Elliot.
Perfect. Elliot, take it away.
All right, you can go to the next slide. Cool. So just a couple notes here. So following up from the Dev Lab and improving our communication, we've been making some updates to the website. Just in terms of the general flow, making things more accessible, like documentation or installation and usage for new users in particular. Let us know if there's anything on the website that's missing. We're trying to make the events more visible, make more of the event summaries and some of the artifacts that have come out of the event more accessible here too. In addition to the website itself, the documentation, we're working to update this. And as James was saying, trying to include a lot of the material, the tutorial material that was at the Dev Lab in the documentation. So we've got a few of those tutorials and the content moved over, and we're trying to move the rest. We're also looking for new bits of content, particularly around porting to XLA, utilizing it as a library, as well as just optimizing XLA for all the different use cases that we have on the different platforms. So being able to work with flags for both code generation as well as things like horizontal scaling, making sure that all that stuff is well documented so that the XLA team is not a bottleneck in terms of getting you answers. And then the last thing that I'd like to talk about is currently we have a number of communication channels for us working as a community, and we're wondering if we can deprecate any of these just to help focus our efforts so that we're monitoring far fewer channels. So the first thing we're doing is we're getting rid of OpenXLA Discuss, that mailing list, and everything will just be sent on OpenXLA Discuss. So I don't think that's a big change, but just as an FYI. Discord is still going to be happening. GitHub discussions and GitHub issues, there is some activity on there, but we might turn those off depending upon what feedback we get, but please let us know. And then we have a new contact group/email, which is just maintainers@openxla.org. So please, if you have direct feedback for us, don't hesitate to email us there, and just let us know if there's anything that we can do to improve communication or the website or any of the documentation. We're happy to do so.
Great. Thank you so much, Elliot. Again, I think the big takeaway is give us your feedback. Thank you for the feedback for DevLab. The same with the website and communication channels. The more we know, the more that we can help. All right, now I'm going to turn it over to our awesome AMD team. Take it away, folks.
Yeah, I can just kick it off. Thanks, Aditi. Yeah, just to sort of set the stage, again, following up from what James was saying, we had a very nice session with our partners, developers at OpenXLA, and so this is one case study with AMD, which of course our goal is that we can replicate the success as much as possible. So excited to go over this. Next slide, please. Just to sort of set the stage, what's the overall goals for 2024 for the build and test. Of course, we want to make sure that things are robust, migrate more and more internal tests to external, or provide as much visibility as possible to our external partners who work with us through OpenXLA to have fewer of the breakages happening internally behind some of the hidden wall. We want to avoid that and have more of these happening out in the open. Of course, the performance is key. How can we do more performance evaluations in OSS? We'll talk a little bit about that. Doing a lot of migration of platform, for example, Docker images, which have been historically happening on TensorFlow. And now that we are doing a lot of that stuff on OpenXLA, so doing a lot of migration on OpenXLA itself, so that developers and partners don't trip over the overall flow of these CI systems, and then of course the overall again GitHub Actions which exist in TensorFlow today. For today, the focus is the AMD ROCm build and test CI, and so we'll dive a little bit deeper into that with our friends at AMD. I do want to call out a few things before I hand it over to Jay and Xiao. Is that Our goal is to basically run pretty much all our, roughly we get 2,000 CLs and PRs in OpenXLA. We want to run that through this external infrastructure. And again, like I said, we would want to replicate that across multiple hardware. Then we think that we have enough capacity available today to run the build and test systems, given the overall volume of OpenXLA PR. And of course, things which are more forward-looking, which is how can we add more performance-related micro benchmark tests or things regarding code gen or fusion and cost models, so that these evaluations again can also happen out in the open. With that, I will hand it over to Jay and Chao, and they can take it over.
Yeah, thanks. I'll probably let Chao talk most of this. I did want to give you some thanks, Praneeth, for your help on helping us get this set up. It's definitely a collaborative effort here, so I very, very much appreciate that. But so we'll go ahead, Chao, let's go ahead and walk us through this. Chao did a lot of this work along with Praneeth, so over to you, Chao.
Yeah, thank you, Jason, for the introduction and Praneeth for the opening. Yes, as we know, we had landed the first PR for ROCm enablement last year, April. Since that, we have submitted and merged over 290 PR in OpenXLA. If you see the right figures, for example, HEPLAS LT, HEPGraph, Triton Future, FPA, PRT, blah, blah. We have more things in the pipeline and plan too. But if you search in the ROCm fix, over 50% of PR is about fixed building bridge. That's not only add a lot of pressures on ROCm side to add more works, but also add more pressures on the upstream reviewer to check our PR, and this can be completely prevented with pre-submit building checks. But the problem here is there's no community building CI enablement in ROCm, in OpenXLA report. Yes, next slide, please. Next, yes. So that's what we're gonna mainly focus today. So we're gonna have the pre-submit CI on the every single PR in OpenXLA by webhooks. So as every OpenXLA developer, we want to stability and fast time to get the CI results. Therefore, we provide a dedicated AMD MI250 for now, and we are happy to provide more CI capacity depending on the number of PR or CR later on. And all these nodes are hosted by cloud providers, which provide product level, server level agreements. And to have the fast CI results, we can finish the CI job less than 15 minutes. And before the meeting, I checked the CI results. It only takes 6 to 8 minutes to finish the CI result. And this can be adjustable in order to balance the CI task coverage and the job completion time. To achieve that, we provide like 10 public open source unit tests, as you see the right list there, to prevent the building and the text bridge on the ROCm sides. And once the public unit tests have been renamed, we will change all the our CI sites accordingly as well. And more importantly, all the CI log is public accessible. So the PR and the CI owners can check. If you see the left figure on the bottom side, so that's we already bring it online. You can check the details on that. You will see all the public CI logs on the side as you check on other CI job as before. So which means a PR and the CI owner will have the responsibility to check the CI and fix the themselves. That's could reduce huge number of PRs from our side as well. And only if there's something is about loading the AMD hardware, that's we are happy to can help and fix it on our side as well. Next slide, please. And yes, next for later on, we are interested to bring some micro benchmarking for the performance evaluation and regression detection, for example, for the code generation and the cost model for the kernel fusion I mentioned before. And more importantly, later on, we can have an end-to-end benchmarking that's have all the opens. We're going to choose open OSS model for tracking the performance on the MI215 for now. And the one of big important feedback we got that we need to be be careful about avoiding overfitting on this benchmarking on this OSS models from this benchmarking. Yeah, that's pretty much everything from our side. Yeah.
Perfect. Thank you so much, Hao and Jay. All right, let's keep moving. ByteDance, take it away.
Thank you. Next slide, please. Here's a bit of a little recap from the dev lab. First, I want to mention that our main focus for this lab session was mostly focused on stable HO. So for our pipeline, it's mainly like we have a bunch of PyTorch models, and we lower into like a Torch MLR, basic Torch dialect, and then to the stable HO, and then to different backends we have. So our focus here, like we want to use the stable HO interpreter as a validation, basically a reference backend to compare with PyTorch original PyTorch model. And in that sense, that we will need the stable HO dynamic shape support. Of course, like there's a bunch of model that with dynamic shapes. And optionally, that we also have a need that we probably want a multi-machine interpretation with some collective ops within the model. Like, and beside the interpreter side, we also like want a ability to be to do the serialization to support the compatibility, and which is quite important for production need. And that's the basically the recap of background from the dev lab. And next slide, please. And so during the lab session, we have a bunch of like deep discussion with the stable HIO team, and thanks for that. And to our need, like from the discussion, basically, stable HIO team will help us to resolve the following issues that we have identified together. So particularly that stable HO team will help us to improve the reference interpreter, and especially dynamic support, and some of the migration issues that we migrate from the MHO to stable HO. There are minor some issues that we identified. Also, that there are some comparison issues with the PyTorch export. So if you want to see the detail, you can try to go to the GitHub like issue to see all the details that we identified. And thanks for that. And yeah, next slide, please. Yeah. Okay. So from the ByteDance side, excuse me. I will like just to focus on two part. One, the first one is the stable HO reference interpreter, and because our current reference backend is basically the stable HO and to LinArc and CPU CodeGen to verify, to do the verification. And so we are trying to integrate the stable HO interpreter. Here's a working press PR that's doing the effort. And from the suggestion during the dev lab, and we got the suggestion like we used different passes that to transfer, basically to transform the dynamic graph to a refined or static graph. And we have been like trying those efforts, and it could work for some of the cases, but of course there are some issues that we will work together with the community to improve that. Basically, the particularly like we have the requirement like for a better interpreter performance, and we have we basically want a good ops support to support more cases and to transform the dynamic ones to the static one. Yes, and then for the second part, which is the next slide. This is looks like previous one. Yeah. So for the serializations, we got suggestions as well to do like the shape support in the version stable HO, basically to utilize the composite primitive to write the operation that's not supported. And we have identified and experiment with those suggestions, and we find like it's promising. We have using that in the front end compiler part to wrap those ops into a compositive ops, and then to do the serialization. And then in our backend compiler, we deserialize that, and we insert back for the functions, and to be able to work for a couple of ops. But of course, we also like there's a devils in the details, and we are identify some improvement that could be possible, and we will work together with the community and the OpenXLA team to improve that, to make the stable HOA more attractive, like model IR to the community and to the overall system. Thanks for that.
Perfect. I know we only have 3 minutes left, so let's punt this topic for the next community meeting. Thank you, AMD and ByteDance team. That was amazing, and we can't wait to hear more from our other partners as well. All right, so let's do this. Let's go ahead and wrap it up. Please provide your feedback on our usual discuss email thread, and we can't wait to meet you all again and talk during next month's meeting. Thanks so much, everybody.
Thank you.